Okay, to wrap up, any supervised learning method tries to learn the association between predictors from one side and the target from another side. We need to measure how successful the method is in learning such association. So just saying that I have learned something is not enough. You have to be evaluated and assessed in order to know whether you actually have learned something or not. This measurement, the measurement of the performance, the measurement of learning, is done by a performance metric. And this performance metric actually measures the quality of prediction as a proxy of quality of learning. A performance metric for a classification problem is accuracy. And I introduced accuracy because it's simple, it's common, it's very straightforward. And we use all these concepts in this framework. We split our data into training and test subsets. We train our model on the training set, and we measure its performance on this testing set. So training set is more like the mock exam, and testing set is more like the actual exam. Or better to say, you have 100 questions and answers. You split it into 80 questions and answers and 20 questions and answers. You learn from this, and then you assess yourself on the second one. The second one is similar to testing data set, and the first one is similar to training data set. Model's performance on the testing set is our ultimate and final goal. But the model performance on the training set is important for model diagnosis. This is a topic that we come back later. For now, let's just keep in your mind that our final goal is to train a model in order to perform very well on the testing set. The performance of a method depends on a few determinants. So, the performance of a method is a function of a few things. Features or predictors. The more relevant and straightforward the predictors, the better the performance. Training set. Training data should be comprehensive, i.e. your mock exam should have all possible questions or similar possible questions that might be asked in the actual exam. If you do this split, and then this testing part, that 20 questions are from one chapter, and that 80 questions are coming from another chapter, then this learning is not going to prepare you for the assessment. So training data set should be comprehensive, should be representative of the problem. And also hyperparameters of a method. The parameters that the method cannot adjust itself. Changing them would change the behavior of the method, so does the performance. So we want to have more straightforward features, a comprehensive and representative training data set, and we want to tune our hyperparameters to the best values. The thing that is very, very, very important is not all methods are equally good for a specific problem. So recall that churn problem. Not all the methods that we will learn one by one, a few of them in this week and the coming weeks, are equally good. So let's say the methods are decision tree, random forest, neural network. These are not performing equally well on a specific problem. So by changing the method, we might get better performance. Therefore, This is this slide includes hints to improve the performance and to remember to recall that and to underline that different methods would have different learning abilities for any specific problem. We would have one dedicated lectures on improvement of the performance of models. We will go through these things. But for now, it's important to recall that we have different methods and their performance for different problems are not equal. Okay? So far, so good.